Day 13 of 75, and today we turn Python's dict into a precision instrument. Here's the thing, you already reach for default dict and counter on instinct. But can you explain why your solution is O, N, instead of O, N squared? In the next 5 minutes, you'll learn the 5 hash map patterns that show up in 80% of interview problems and exactly why each one works. Let's start by watching a solution fail. Longest substring without repeating characters. Beginners reach for a set, add characters, and when you hit a duplicate, shrink the window. But with a set, you don't know how far to shrink. You end up removing one character at a time in a loop, and suddenly you're back to O, N squared. The fix is a different data shape, a dict mapping each character to its last seen index. Now when you hit a repeat, you jump the left pointer directly past it. Same problem, but the key schema changed everything. That's the core lesson. The dict key is your algorithm's fingerprint. What you store as the key encodes the exact question you're asking the data. Here are the 5 patterns. 1. Frequency count. Key is the element. Value is how many times you've seen it. 2. Complement lookup. You store what you've seen to check for a partner. 3. Sliding window with a frequency map. 4. Grouping and bucketing by a computed key. 5. Prefix sum with index tracking. Recognize the shape before you write code, and the schema writes itself. Let's live code toSum with pattern 2. You want 2 numbers that add to target. The naive double loop is O, N squared. Instead, scene equals empty dict. For I, number in enumerate nums, compute complement equals target minus number. If complement in scene, return scene of complement and I. Otherwise, scene of number equals I. 1 pass, O, N time, O, N space. And the gotcha. You check for the complement before you insert the current number. Insert first, and a single element could match itself. Order is correctness here, not style. Now group anagrams. Pattern 4, bucketing. The instinct is to sort each word and use the sorted string as the key. Eat and T both become AT, so they land in the same bucket. That works, but sorting each word is O, K log K. The faster key, a tuple of character counts, length 26, built in OK. Tuples are hashable, lists are not. So tuple is mandatory here. Use default dict of list, append each word to its bucket, return the values. The key schema choice directly sets your complexity. Why is the hash map version O, N, and the brute force O, N squared? Under the RAM model, a dict lookup and insert are O, 1, average. The hash function jumps you straight to the slot. So a single pass over N elements doing constant work lookups is O, N total. The brute force compares every pair. That's N times N over 2 comparisons. O, N squared. You're trading O, N, extra space to collapse a nested loop into a single one. That trade is the whole pattern. Spot the bug segment. You're iterating a dict and deleting keys inside the loop for K and counts. If counts of K equals 0, del counts of K. Python raises runtime error, dictionary change size during iteration. The fix, iterate over a snapshot for K and list of counts, which copies the keys first. 2 more traps fast. Negative numbers as dict keys are totally fine. They hash like anything else. And a list can never be a key. Unhashable type error, because it's mutable. Reach for a tuple instead. Quick cheat sheet. When does dict beat set beats sorted? Use a set when you only need existence. Is this here? Yes or no? Use a dict when you need to attach data to the key, a count, an index, a bucket. Sort first only when you need order or you genuinely can't spare the space. Day 13 done. The takeaway. Pick your key schema before you write a line of code, because the key is the question you're asking. Subscribe for day 14.